The earliest evidence of tool use is found among the chimpanzee and bonobo species. These hominids use objects such as twigs, leaves, rocks, and branches in various ways to complete certain tasks. Some of these tasks include, but are not limited to, feeding, drinking, cleaning, weaponry, and reaching faraway objects. This use of tools proves that the behaviors are passed on to offspring through observational learning, and it can be argued that tool use is adequate evidence of culture. This use of tools can be dated up to 4 million years ago. Moving forward, the earliest stone tool making developed by at least 2.6 million years ago. The early Stone Age includes the most basic stone toolkits made by early humans. The oldest stone tools, known as the Oldowan toolkit, consists of hammerstones that show battering on their surfaces, stone cores that show a series of flake scars along one or more edges, and sharp stone flakes that were struck from the cores and offer useful cutting edges. The presence of stone tools falls roughly between 2 and 3 million years ago, that would have given our distant ancestors a greater variety of habitats than they would have known before, such as woodlands and grasslands. This knowledge is explained by paleoanthropologist Thomas Plummer at Queens College in New York. In addition, he said that tools may have allowed hominids to be more adaptable, extracting food from a greater range of areas. Olduvai Gorge is known as the place where Lewis and Mary Leakey found evidence that helped us to understand early humans. Thanks to the Leakeys' work, we have been able to learn more advanced information about our early human ancestors. Additionally, people today are continuing the search at this famous site in Tanzania. The chopper stone tool of the early Oldowan industry was the first found at the site, and it led to findings such as the hand axe in the more recent Acheulean industry. A group of scientists from all over the world founded the Olduvai Geochronology Archaeology Project to focus more on connecting the transition of the two industries. The scientists are taking a closer look at bed 2 by analyzing the stratigraphy and volcanic ash. These beds are the same ones that held significant findings years ago, and the team is hopeful in their efforts will be successful. By the time that Homo erectus emerged, about 1.76 million years ago, early humans began to strike really large flakes on the tools and then continued to shape them by striking smaller flakes from around the edges. The resulting implements included a new kind of tool called a hand axe. These tools and other kinds of large cutting tools characterize the Acheulean toolkit. Moreover, these tools reveal a higher level of cognition and recognition of shapes and spatial awareness that is more sophisticated than what chimps could do. During this time, early humans ended their arboreal lifestyle completely, or life in the trees. Homo erectus began carrying tools with them instead of dropping them after use. This is cognitively significant because it justifies that the use of tools became integrated into early humans' day-to-day schedule, something that they relied on regularly. The Acheulean toolkit was made for an immense period of time, ending in different places by around 400,000 to 250,000 years ago. Innovation increased during the later Stone Age. Raw materials such as antler, ivory, bone, and stones were used by groups of Homo sapiens. Also, the level of manufacturing tools increased. These tools obtained sharper points and thinner shafts, enabling early humans to make projectile weapons, arrows, and throw darts. Different kinds of groups started to find their own cultural identification and began developing their own way of constructing things. These tools were characterized as the Upper Paleolithic toolkit found in Europe and Africa during the later Stone Age. The Upper Paleolithic toolkit began to be more of a cultural assortment and, in addition, it contained very diverse tools and artifacts. Over time, early human species began to improve the tools that they were using, making them sharper, stronger, and more effective. This eventually sparked a movement toward a hunting lifestyle, and human species are seen using spears and other tools as weapons. These weapons were used to hunt bigger game by themselves, instead of salvaging the remains of a carcass previously killed by a large non-human predator. This advancement of improved tools in the action of hunting exposes significant cognitive development as early humans began to show signs of improved strategic planning, organization, and teamwork. Additionally, the controlled use of fire began around the time Homo erectus emerged. This ties in to the subject of tools in that without these tools used in hunting, the species would have little protein to cook in a fire. Eating raw meat is harder for the human body to digest. With the use of fire, species were now able to cook not only gathered food but meat harvested from hunting as well. The digestion of cooked food, especially cooked meat, gave the body more energy that could be distributed to the brain, thus improving cognitive abilities. Therefore, though indirectly, the advancements in tool use influenced human ancestors' cognitive development in a positive way. Within the span of the archaeological intrigue, many modern-day archaeologists are most interested in the reconstruction as well as the records we have found in ancient tools. Before diving into how tools were made, there are a few things to know first. Jorge Simeo states in his article, Tools Evolve, the artificial selection and evolution of Paleolithic tools, that tools are made through a simple process, fracturing a stone that produces sharp edges. Archaeologists have come up with a name in order to explain this process. It is called knapping. Knapping directly refers to the stone fracturing process. The person who conducts the fracturing process is called the knapper. These hominids deliberately fractured the stone and dealt with much force as well. Not only does this correlate directly with primary motor control, but also with hand-eye coordination of the hominid. Some of the first tools appeared about 2.5 million years ago, and the remains that Simeo speaks about are found in Ethiopia. They were referred to as Mode 1 tools. That term was coined by Graham Clark in 1977 and has to deal with the distinguishing characteristics of the tools. Specifically the edges. The tools allowed for chopping, crushing, and heavy cutting, but not much else. The main focus that Simeo had was the symmetry evident in not only the Mode 1 tools, but bifaces as well. Bifaces were made by detaching a large portion of the stone from a boulder-sized stone and used a two-handed hammering technique. The knapper then further changed the tool by trimming the edges of the stone until the trimmed side was similar to the natural edge, thus giving it the name biface. There are two types of bifaces recognized, and they are the hand axe and the cleaver. Hand axes clearly have a point or tip at the end. Cleavers, on the other hand, have a trimmed portion of the stone that is perpendicular to the natural left side of the tool. Although reconstruction of ancient tools, as well as archaeological evidence, symmetry being evident in tools, some argue that this congruency is only seen by archaeologists today. However, later records, around 500,000 years ago, show that clear hominid symmetry is apparent. This true congruency tells that the sides are not just mirrors of one another, but are actual duplicates of the natural sides. How is this possible, you might ask? It all goes back to the cognitive development of the early human ancestors and humans. Simeo states that there must have been knowledge of what different ways knapping and changing the stone would do and how it would benefit the subject making the tool. Stone tools and artifacts have been found in Ethiopia and have contributed greatly to the modern era. Tool making in early hominins is an effective and essential skill that leads to problem solving and cognitive abilities. Diverse technologies play an impact on the advancement of tools and its role in components such as language and bipedalism. Language, which is found in evidence of Oldowan tools, is a major subcomponent of tool making. Also, language is responsible for the communication skills that developed among early human species over time. Specific tools that act as evidence behind language in the development of social skills until the hammer, stone, and hand axe. Also, the numerous amount of evidence in stone tool artifacts provides a connection to both tool making and language. This correlation between tools and language found in the Paleolithic age provide behavioral, chronological, and contextual evidence. The communication skills that arise from language are found in the brain. In terms of language in the brain, the left hemisphere of Broca's area is largely responsible for providing evidence of linguistic behaviors and a connection to tool making as well. Both tool making and language have been shown to create not only a significant relationship, but also impact the way in which early humans behaved and developed social skills that we have adapted and evolved with today.